Have you ever wondered how simple things create something complex? Take a water molecule, just two hydrogens and an oxygen. But trillions interacting? You get oceans and waves. That's emergence. Today, we're diving into how simplicity spawns novelty, from flocking birds to AI. Stick around, because this idea could unlock the future of AI. Hi everyone, welcome back to Eduverse. Hit that subscribe button for more mind-expanding content. Let's get into it. Emergence is when novel patterns pop up from basic parts interactions, unpredictable from the parts alone. It's the bridge between reductionism and the big picture. The universe's way of saying more is different. Nobel physicist Philip Anderson said it in 1972, new properties appear at each level of complexity. Not all emergence is equal. Weak emergence is explainable, like simulating a flock of birds with simple rules. Strong emergence, like consciousness from neurons, might be fundamentally irreducible. We'll debate that later. This idea goes back to Aristotle, who said the whole is more than the sum of its parts. In the 19th century, John Stuart Mill noted how hydrogen and oxygen make water, which is nothing like either gas. G.H. Lewis coined emergent in 1875 for unpredictable properties. It resurfaced with chaos theory. Today, it's central to complex systems science. Let's see emergence in physics and chemistry. Temperature and pressure emerge from billions of colliding gas molecules. Superconductivity involves electrons pairing up for zero resistance flow. No lone electron does that. It's a group thing. Galaxies emerged from gravity pulling on uniform post-Big Bang stuff. Chemistry also shows emergence. Water's wetness comes from hydrogen bonds, creating surface tension and solvency. The Belousov-Zhabotinsky reaction creates swirling waves and spirals from chemical feedback loops, not a blueprint. Biology truly shines with emergence. Life likely began as simple chemicals self-organizing into self-replicating structures. A modern cell is an emergent factory. Proteins and DNA team up for metabolism and reproduction, far beyond individual parts.
Ant colonies or termite mounds have no boss. Individual bugs follow pheromone trails, creating megastructures and smart foraging.
This is stigmergy. Bird flocks follow three rules: don't crash, match direction, stay close, and swoop like a single organism. We simulate this, proving its weak emergence. The brain, with 86 billion neurons, sparks memory, emotion, and consciousness. The hard problem is how subjective experience emerges from electrical zaps. Could thoughts just be neuron firings? In social systems, humans are masters of emergent chaos. Adam Smith's invisible hand shows selfish actions creating market prices. But herd panic can cause bubbles and crashes. One seller spooks others, and the market falls. Thomas Schelling's segregation model shows mild preferences for similar neighbors lead to sharply divided cities. This emerges from bottom-up choices, not top-down hate. Urban vibes, like artsy districts, also self-organize. Even in math, proofs emerge from axioms, like Pythagoras' theorem. Truth emerges logically. Conway's game of life, with simple rules, creates stable shapes, oscillators, and gliders. It's Turing complete. Gliders emerge without explicit rules. Play with it online. It's addictive. Emergence has limits. Reductionism is great for parts, but not for wholes. Game of life rules don't predict complex patterns without simulation. That's computational irreducibility.
In climate, one CO2 molecule is nothing. The system's emergent warming is everything. We need better tools.
The debate. Is strong emergence real? Physicalists say everything boils down to physics, no downward causation. Proponents argue it's like software guiding hardware. Can physics explain what it's like to feel joy? Abstraction helps. Emergent levels have their own laws, like fluid dynamics predicting rivers without quantum details. Now, let's apply this to human and AI intelligence. This is exciting for our tech-driven world. Old AI coded rules. Deep learning lets abilities emerge. Neural nets identify cats by self-organizing features. Large language models predict words, but scaled up, they show emergent abilities like math and coding. These abilities appear at certain sizes. Weak emergence, but it hints at AGI. Will bigger models keep surprising us? Human intelligence isn't rote recall. It emerges when you problem solve, like inventing sonar to calculate ocean depth. That's creative synthesis. Our brains generate novel solutions from abstract models, adaptive and flexible. AI's future, scaling works, but emergent behaviors are unpredictable. We need to engineer better emergence, favoring truth and ethics. Can weak AI emergence mimic strong human consciousness? Perhaps with embodiment or evolution. AGI might emerge from interacting networks. Emergence is the universe's secret sauce, turning simple into spectacular. From physics to minds, it drives complexity. Weak emergence explains flocks and LLMs. Strong emergence probes consciousness. Mastering emergence is key for global challenges. Is consciousness strongly emergent, or just physics we don't get yet? Drop your thoughts in the comments. If this sparked your curiosity, like, subscribe, and hit the bell. Share with a friend. Thanks for watching. See you next time.